Almost festive, not Christmas song. There's so much concrete in the Hoover Dam. Do you know how much? I could give you like 7-digit figures and other little tidbits, but I don't think any of it would really hit home. The concrete in the Hoover Dam, there's so much of it that if the engineers of the Hoover Dam let it cool by itself, concrete when it cures releases a lot of heat, just part of the chemical reaction. If they let it proceed naturally, they estimated that it would have taken 125 years to cool down. So instead, they installed a system of cooling water pipes throughout the Hoover Dam that made the process go a lot quicker. But for the sheer volume of concrete in the Hoover Dam, which you are seeing here now, with that amount of concrete, you could pave a 16-foot wide highway from San Francisco to New York. Hey, I'm hoovering over here. What a feat of engineering, with many feet of engineering. And welcome to another edition of Footnotes, the companion show to Because Science, where I take all of your comments, questions, and corrections and I put some cooling pipes into them. Fact pipes. Then I tell you what's coming up next on this channel. Hint, But getting right down to it, in the last episode of Because Science, we were trying to figure out what might be inside an actual super serum that would be able to take you from zero to hero, or Chris Evans to Chris Heavens. Don't you shake your head at me. I suggested a number of changes that a super serum could make, mostly genetic, in partnership with Novartis, and they could possibly lead to extra strength, extra stamina, all that sort of good stuff. You can watch the episode on YouTube if you haven't yet, but what did you have to say? Our first comment comes from Mr. Streetly122, who says, so this is really cool. I stumbled upon the MSTN gene, the muscle gene that we were talking about, a while back, and over time I've been compiling a list of genetic mutations that have occurred in humans that could create a superhuman. Here's my list. LPR5, a mutation resulting in 8 times higher bone density, super sprinting gene, super sleeping gene, purple irises and no body hair. The last two are more or less vanity mutations for men, but Alexandria's genesis would be incredibly helpful for women. Here's the thing, you have no idea what's incredibly helpful for women. A, B, or 2. Alexandria's genesis is not a real thing. Also, the mutation with 8 times higher bone density, it means they can't swim and they got really thick bones, but they also have like terrible diseases associated with that. It's almost like you're missing information on a number of fronts about like more than half of the population. Crazy. Next comment comes from Grant Baugh, who says the idea of the serum being a virus was actually covered at one point in the comics. I said that it wasn't. In issue 384, Cap received a physical evaluation during which the doctor said, quote, the serum was not a mere drug whose effects would have been metabolized and eliminated over time, which we said in the episode. Instead, it must have been some sort of self-replicating virus. So indeed, as Grant points out, the comics did indeed touch on the fact that whatever the super serum is, it can't be just a simple chemical, because that will eventually be metabolized and excreted by any super beefy body. So I'm surprised the comics actually got part of it right. I mean, they still have people in movies swinging on lightning, but, you know, one step at a time. Our next comment comes from Ayana, who says, I've actually been wondering about the immediate results depicted when characters undergo their radical transformations. What would happen to your muscles, bones, and skin if your muscles suddenly just began to inflate to massive sizes? This is one of my problems with the Hulk. One, all of that muscle mass just can't come from anywhere. You can't create or destroy matter. So it's like, people say alternate dimension, but what do you mean? Hulk's getting fifth dimensional meat inserted into his body? How? Why? Doesn't make sense. Secondly, or B, if you were to increase in size a la Bruce Banner and rip your purple pants, but never off, it would do terrible things to your body. Most people who go through these changes lose a lot of weight, gain a lot of muscle. When it's in a short amount of time, they have radical physical changes that they have to deal with. If your muscles suddenly increase in size 6 or 7 times, are your bones keeping up with this? Are your tendons? Are your ligaments? Are you just snapping every bone in your body? That's why I kind of like the depiction for werewolf transformation even more than something like Hulk transformation, because in horror films, the good ones with really good practical effects, when you see a werewolf transformation, transform, it looks painful. Fingers are extending, you hear cracking sounds. It's this disgusting full body horror show, as it should be, but it looks like it's affecting the body much more like how it probably would affect the body. So you heard it here first. Werewolves are more realistic than the Hulk. But the nerdiest comment at the time I'm filming this episode, I am giving to one Lindsey, who says, and shares a very personal story with us, who says, speaking on genetic disorders also being superpowers, I have a genetic condition that affects the collagen production in my body. It's called Ehlers-Danlos syndrome. The disability part is near constant joint and organ pain and a heart condition as a consequence of faulty collagen. The superpower part, though, is a super flexibility because my ligaments are like rubber bands instead of inflexible steel cables like they should be. My nickname in dance classes was literally Elastigirl because I was usually the most flexible to the point where I was borderline contortionist. Now that I'm in my 20s, it's more of a disability since I'm going into IT. My fingers are so flexible and weak that typing can be painful. My spine and my neck are so flexible that my ribs dislocate and my spinal cord becomes inflamed from being stretched and compressed. Whew, this syndrome sucks. But it was cool when I was younger. Basically, I'm a Belta from The Expanse because gravity affects my body more than the average person. On my cardiovascular system, it causes blood to pool in my legs because my veins and arteries stay expanded rather than contracting. This causes brain fog, dizziness, and eventual passing out from lack of blood to the brain. Abraham Lincoln had a related genetic connective tissue disorder called Marfan syndrome, which made him super tall and strong. He was known for being an amazing wrestler with an incredible jawline. But this condition is also why he had to walk with a cane in his later years. Well, I think what we tried to outline in the episode is that, yes, there are ways for genetic changes to make you superhuman, but obviously they come with risks, they come with drawbacks. There are a number of knock-on effects that are too simple to cover in a 10-minute video, and a number of you point out the ethical implications of doing something like this. But Lindsey, thank you so much for sharing your personal story. I hope that wherever you are, whatever you're doing right now, you are doing fantastically, and that you were once Elastigirl in your younger years. I think that's kind of awesome. And you know what else is awesome, Lindsey? You are definitely a super nerd. But of course, I'm not always right. So what did I get wrong last week? Oh, and I'm sure you definitely want to correct me on a lot of stuff that I say here in the void. And if you want to do so, you want to be notified about when I put up them videos. So make sure you're liking, commenting, and subscribing, hitting that notification bell so you know everything that I'm doing every step of the day for me. Our first correction comes from Kaya and a number of you who say, most people can't do 3 pull-ups? Why you call me out like that, man? Because most people can't. A lot of you seem to have issue with me saying most people can't do 3 pull-ups. I think it's objectively true. If you base just like on what we require of students, say in the Presidential Fitness Challenge, if you're from the United States, you know what I'm talking about, they don't require all that many. And most people, I used to train people in the gym, most people I find cannot do a single pull-up. So, if anything, you're just proving my point. Pull-ups are really hard. Pull-ups are really, really hard. It's putting your entire body weight just on a few muscle groups here. You have to work very hard at it. It's not something to be ashamed of. It's a very hard exercise. Most people can't do 3. Most people can't even do 1. It's something you got to train for, like anything in life. Darren Wood has a correction who says, the whole can't get drunk because of crazy high metabolism thing always confused me. Surely Captain America could get a bit buzzed. I actually did an episode on this once. Just a second. I called it, How Much Can Captain America Drink? It was published in July of 2016, episode 93. And in that, I used the blood alcohol content formula to calculate how much Captain America could drink, how quickly to get buzzed and drunk. And I did this because, like what you said, metabolism is a factor. And in the first film, they say he has a metabolism that works 4 times faster than the average man. And because metabolism is actually a factor, a variable in the blood alcohol content equation, we can actually put ×4 in the equation and calculate how buzzed old Steve can get. And what did I say? What did I say? Hashtag CapChug. All right. To get drunk, Captain America would need, because of his enhanced metabolism, to chug a gallon of beer in less than 5 minutes. A gallon of beer, or a half a gallon of wine, or a pint of liquor in a minute. a pint of liquor in a minute, or an entire keg over 24 hours. That guy likes to party. Ain't no party like a Steve Rogers party, because a Steve Rogers party technically lives to 112 and then dies after Peggy does. Is that what happened? Who cares? I never want to think about the logistics of that movie ever again. Our next correction comes from Langista02, who says, typical lab people you used in the video, they always wear safety glasses in a place where there's literally no danger to their eyes. I'm only bringing this up because often when you have what's called in the biz B-roll of scientists, they most often look very much like scientists. They're wearing lab coats, they're wearing safety goggles, they have beakers and stuff and Bunsen burners going. And I'm only bringing this up because I want to point out scientists don't look like that. Like, yes, if you go into a lab where active work is being done, yeah, you can find safety glasses and lab coats. But for the most part, scientists look like everyone of every race, color, gender, sexual orientation, everything. Scientists are like everyone. They're just a sampling of the population. And I think it's time for you have to wear a lab coat or else no one will think you're a scientist. I think it's time for that trope to die. It's not entirely scientists' fault. I will say from personal experience that when TV shows, production companies, when they want to make a sciencey thing, they will ask the science person to, hey, could you put on a lab coat for this scene? Because, you're a science person. It's perpetuating the stereotype. And I think it's time for it to end. Scientists look like everyone. Tweet at me if you're a scientist with a selfie of yourself with hashtag, this is what a scientist looks like. Yeah. But the nerdiest correction at the time of this video, I'm giving to two-time super nerd already, Jack Lindy, who says, Kyle, there are two things you missed and or glossed over. The second thing is ethics. And I did kind of gloss over this because it wasn't the point of the episode, but it's important to highlight here. So ethics. You glossed over it by simply saying, if it's to make superhumans, then we shouldn't do it. But if it's to save lives, we can do it. But you didn't explain why, and that's super important. The first obvious point of ethics in gene editing is the risk. Like I said, CRISPR and other gene editing techniques aren't 100% accurate. Most of the times they fail. They don't make the necessary alterations, but they do sometimes make an alteration to a location at a spot other than the intended sequence. Can you imagine what would happen if you were trying to swap out the genes that controlled red blood cell production in bone marrow, only to have your genes located in the middle of the genes that code for the production of proteins for cell walls? You would go from having a low healthy red blood cell count to having a high count of unhealthy red blood cells. These risks are too much for a healthy individual who's just looking to get ripped. This is very important. Doctors, scientists, medical researchers, in the name of science, can't knowingly subject people to treatments, techniques, gene editing that they know has some substantial risk or unknown risk. It's one thing to be completely informed about what might happen to you and then agree to undergo some process or procedure. But gene editing right now, as hot as it is as a field, is still relatively speaking in its infancy. And so to impose that on people just with the hopes that they get ripped, not to cure sickle cell anemia or what have you, that's less of a medical imperative that would warrant this kind of risk. So right now, when things are still in so much flux, when there is so much danger, it's just unethical. And Jack, for pointing that out, you are now joining an exclusive club, a 3-time super nerd. Third. And now, moving right along to this week's episode of Because Science. This week's episode is, how does force lightning work? Bleh. That's right, in this week's episode of Because Science, we're looking into the powers of Palpatine and other Sith lords to figure out how force lightning might work. How much power would it actually take? What would you have to do? Would that power be unlimited? No. But find out this week more of it. But before we figure all of that out, please go watch the last episode if you haven't yet, all about making a real super serum, and leave me your best, nerdiest comments, corrections, and questions at youtube.com/becausescience, facebook.com/becausescience, and at becausescience on Instagram and the Twitter. And don't forget, it's gonna be the holidays very soon. You're gonna be flying, you're gonna be driving, you're gonna be around a lot of people, more people than you're usually around, so wash your hands. Sneeze bacteria can travel to basically every surface in the house in like under 2 hours if there's a lot of people around. Wash your hands and stop hugging your relatives. You can tell them it's for hygiene purposes.